NASA's self-driving Perseverance Mars rover takes the wheel. The Perseverance rover, NASA's newest six-wheeled robot on Mars, has begun an epic trip across a crater floor in search of traces of ancient life, the U.S. Space Agency revealed on Thursday. According to a NASA press release, the rover team is actively planning navigation paths, composing instructions to be sent up, and even donning special 3D glasses to aid with course mapping. However, the rover will increasingly take control of the drive by itself, thanks to a strong auto-navigation system. This upgraded technology, known as AutoNav, creates 3D models of the terrain ahead, recognizes risks, and calculates a route around any obstructions without the need for extra guidance from controllers on Earth. At NASA's Jet Propulsion Laboratory in Southern California, we have a capacity termed thinking while driving, said Vandi Verma, a senior engineer, rover planner, and driver. While its wheels are spinning, the rover is thinking about autonomous driving. That capacity, together with other upgrades, might allow Perseverance to reach a top speed of 393 feet (120 meters) per hour. Curiosity, which was outfitted with a previous version of AutoNav, climbs Mount Sharp to the southeast at around 66 feet (20 meters) per hour, it added. Michael McHenry, the mobility domain lead and a member of JPL's team of rover planners, remarked, "We sped up AutoNav by 4 or 5 times. We're covering a lot more ground in a lot less time than Curiosity did." AutoNav will be a critical element in enabling Perseverance complete its maiden science campaign on the floor of Jezero crater. Perseverance's target is a dried-up river delta at the crater's edge, where there was once a lake when Mars was wetter than it is now, billions of years ago. Signs of life could be detected on early Mars if it ever took hold. The rover will collect samples over a distance of around 9 miles, 15 kilometers, then prepare them for collection by a future mission that will return them to Earth for study. "We'll be able to travel to locations the scientists want to go much more quickly," said Jennifer Trosper, the project manager for NASA's Mars 2020 Perseverance rover. Trosper has worked on every one of NASA's Martian rovers. "Now, instead of driving around, we can drive through these more difficult terrains. This is something we couldn't do previously." The rover team's input is still crucial in planning and driving Perseverance's route. An full team of experts plans the rover's behavior, whether it's investigating a geologically intriguing landmark on the way to its goal or, soon, taking samples, as well as the navigation route. They can't just move the rover ahead with a joystick because of the radio transmission latency between Earth and Mars. Instead, they scrutinize satellite images, sometimes donning those 3D glasses to view the Martian surface in the rover's vicinity. After the team signs off, they transmit the instructions to Mars, where the rover follows them the next day. Perseverance's wheels were also changed to help with the speed with which those plans are carried out. They have 48 treads that look like slightly wavy lines, as compared to Curiosity's 24 chevron pattern treads, and are slightly larger in diameter and narrower than Curiosity's wheels. The objectives were to improve traction and durability. Early in the expedition, little, sharp, pointy rocks began to puncture the wheels, and our AutoNav failed to dodge them. Perseverance's belly has more clearance, allowing it to roll comfortably over harder terrain, including large rocks. ANAV, or Improved Navigation, is an algorithm and software combination that provides for more exact hazard recognition in Perseverance's beefed-up auto-navigation features. Perseverance, unlike its predecessors, can use one of its processors only for surface navigation, freeing up the main computer to focus on the numerous other tasks that keep the rover healthy and productive. Perseverance was guided to the Martian surface by this Vision Compute Element, VCE, during its entry, descent, and landing in February. It's now being used full-time to plan the rover's itinerary and assist it in avoiding obstacles. The rover also keeps track of how far it's moved from one spot to another using a system called visual odometry. Perseverance takes pictures as it advances, comparing one location to the next to see if it has traveled as far as it should have. Members of the team said they're looking forward to having AutoNav drive. They will, however, be ready to interfere if necessary. It never gets old, according to the planners and drivers.